Hi, hello, good morning. Welcome back to my channel. So today I'm going to start with 15th module of light chapter. So before we move forward, let's see a beautiful picture of a swimming pool. So here you can see a swimming pool which looks shallower than it really is. Have you ever wondered why is it so? But the moment you get into the swimming pool, it will be deeper. But when you look the swimming pool outside, it looks less deeper. Have you ever wondered why it is happening so? Exactly. That's what we are going to learn today. Refraction of light. So let's understand what is refraction and what causes refraction. Okay? Yes, so let's move on. First, we are going to see what is refraction. So in this diagram, you can see a glass filled with water, okay, and a pencil is immersed in it. And did you notice any change in the pencil when it is inside the water and outside the water? Can you tell me what are the two mediums involved in this case? Exactly. So here you can see air and water. Okay, water and air. These are the two mediums that is involved. So what happens to light when it enters a different medium? Exactly. It bends. Light rays bends. So why it bends when it enters a different medium? Absolutely. So the behavior of light with individual particle varies when it goes to a different medium. Okay, so the behavior with the particles in air is different from the behavior of light when it interacts with the water particles. So it is due to the change in behavior of light, or simply we can say due to the change in speed of light. Why the speed of light changes? Because the behavior of light changes when it interacts with individual particles in a medium. So due to which the speed of light changes. Okay? So due to the change in speed of light, the light bends. Now what is refraction? It is nothing but bending of light when it passes from one transparent medium to another due to the change in speed. Okay, so what causes bending? Due to the change in speed. Okay, so let's understand refraction using ray diagrams. So we are familiar with ray diagrams, right? Yes. So let's understand better. So I'm using two mediums, okay, medium 1 and medium 2. And these two mediums are separated by an interface. Okay, this straight line indicates the separation of two mediums. And let's say medium 1 is optically rarer. It's an optically rarer medium, and this is optically denser medium. So what do you mean by the term optically or optics? So since we are dealing with light, we use the term optics. So optics is nothing but it is a branch of science which deals with light. Okay, since we are talking about the behavior of light when it enters a medium, I am using optically rarer. Optically rarer medium is a medium through which speed of light is more. Speed of light is more. Optically denser medium is medium through which speed of light is less. So speed of light is less. Okay, so I have two mediums, so I'm separating them using an interface. So let's see how light behaves when it enters to this medium. So this is dotted line. This dotted line indicates the normal. Okay, this is the normal line. So as you all know, it is an imaginary line which is perpendicular to the refracting surface. Now let's see an incident ray which hits the interface. So it is entering from optically rarer to optically denser. So more speed to less speed. So since there is a change in speed of light, it bends. Now we should know whether it bends towards the normal or away from the normal. So in this case, it will bend towards the normal because speed of light is less. So if speed decreases when it enters a different medium, then it bends towards the normal. Okay? Yes. Now we have an angle formed by the incident ray and the normal, that is angle of incidence, an angle formed by refracted ray and normal, that is angle of refraction. Now, what is the relation between angle I and angle R? So, if light ray is entering from optically rarer medium to optically denser medium, then angle of incidence is always greater than angle of refraction. Why? Because in denser medium, it bends towards the normal. So, angle will be less compared to incident angle. Now let us understand what will happen if it happens the other way. That means you have an interface. This is optically denser medium and this is optically rarer medium. Now I have a normal line perpendicular to the interface and a light is entering to a rarer medium from denser. So what happens? In rarer, speed is more. In denser, speed is less. So less to more, it will bend away from the norm. Now again label the incident angle. This is angle of incidence, that is angle between incident ray and the normal. This is angle of refraction, that is angle between refracted ray and the normal. Now can you tell me what will be the relation between I and R? Okay, I and R. What will be the relation between these two angles when it is entering from a denser to a rarer medium? The angle of incidence will be less than angle of refraction. Okay, these are the 2 points that you should remember. Okay, rarer to denser, angle I is greater than angle R. Denser to rarer, angle I is less than angle R. So what will happen to the ray of light in this case? It will bend towards the normal. And what about this case? Light ray bends away from the normal. Away from the normal. So these are the 2 important points that you should keep in mind when you learn about refraction of light, when light travels from rarer to denser or vice versa. So that's it for today. We will meet again with another interesting topic in our next module. Till then, bye.